going on, guys? Welcome back to another physics episode. And today, Fernando, Evan, and myself, Luke Parker, will be talking about the human cannonball. Today, we will talk about the physics, what we learned and how we applied it to this lab, the math, how we found our results and conducted the tests, our prediction on what we thought would happen, and the results of what actually happened. The physics. What we learned for the constants was keeping the spot for launching the same each time will allow the adjustments to work. Our physics calculations did not work. Although we were correct with our calculations, our course ultimately failed. And other factors, any other factors that changed the course of flight were not taken into account in this lab. Our methods. We measured out the total distance the ball would travel in the x direction along the length of the floor. Secondly, we then marked each x distance between our 4.0 meter course on the floor. Our distances were 1, 1.75, 2.4, 3, and 4 meters. Then, using our formulas, we calculated the y distances at each x distance. Using the y distances, we set up metal rings on ring stands at the calculated x and y distances along the path of the flight of the ball. Finally, using our distances that we calculated, we fired the ball from the cannon over 3 times to try to get it to go through each ring that we had set up while we videotaped the results.
Hey guys, welcome back to another video. Today we're going to talk about the math. We used a bunch of different formulas. We used distance equals initial velocity times time plus 1/2, acceleration times squared. We also used time equals distance in the x divided by velocity in the x. These formulas were used to find the y distance at each x distance during certain points in the ball's flight. We also used vf squared equals vi squared plus 2ad, then we used negative 2ad equals vi squared. This formula was used to find the velocity of the ball shot straight up in the air. Next, we used vx equals vi cosine 35 and vy equals vi sine 35. These formulas were used to find the x and y velocities when the ball was fired at 35-degree angle.
Action. Okay, so these are our predictions. This is what we thought would happen. So at 1 meter, we thought it would be at 0.454 meters tall. At 1.75 meters, we thought it would be 0.76 meters tall. 2.4, which was the middle of the course, it would be 0.82 meters tall. And then as you can see, for the 3 meters and 4 meters, it goes down because this is the peaks, and then it would go down after that. This is our path of flight that we had with meters on here, and then these are meters tall, and these are meters like the length in the x direction. Really. And then this video won't load, but it's like the plane of flight. It broke your computer last time. And then we have our results. This is what actually happened. So we didn't really do it correct, but what happened, pretty much just our methods. We shot it at a 35-degree angle at least 3 times. We missed every single time. We tried it 5 times actually, but we missed each time. We set up 5 rings and we calculated the course's time of flight, but we calculated it correctly, it just didn't work. Summary of our results: the first trial, the ball hit the side of the ring and got launched into the lab tables. The second time, the ball hit the top of the ring and went straight downwards, and the ball went through the first ring, missed the second ring, and continued to miss the rest. And we tried 2 more times and failed as well. Please, don't do this to me. We failed. We didn't make it any of the times. Possible sources of error: uncertainty with the measurements of the ruler, It's not a lot, but it could add a little bit. There was a 14 centimeter wide rings, allowing to take up some of the uncertainty. Air resistance, we didn't calculate any of that in our measurements. The ball was already 14.6 centimeters off the ground. We did subtract that off, but it might have just made some uncertainty, and then with the significant digits and everything. We could have tried angling the ring so that it followed the trajectory of the ball, created a more precise layout of the course, and a better way to hold up the rings than the ring stands that were sometimes unstable. So yeah, in conclusion, we failed.